So hi, everyone. Thanks for joining us in this session today. My name is Darshan Khalsa. I'm in the Department of Plant Sciences at UC Davis. And I want to acknowledge my colleagues, Daniel Rivers and Brent Holtz from San Joaquin County Cooperative Extension and UCANR, and my colleague Patrick Brown, also in the Department of Plant Sciences at UC Davis. Today, I'm going to give a presentation about work that we're doing with organic matter amendments or compost and examining its effect on soil nutrient availability and tree uptake, looking at a California almond system. So an overview of this presentation is as follows. First, I want to talk briefly about an analysis we did with growers looking at their concerns about using these materials and their availability in terms of quality and access for growers in California. This was the sort of the basis that we started with for this work before we moved into a field trial. We initiated a field trial at the tree scale in 2016 and 2017. I'll report those results here today, but that same trial has been ongoing for a number of years now, so we have sort of exciting outcomes to come in the future. I'll go through both the design of that field trial and measurements we took, and then also report on some of these initial results for these non-bearing trees, looking at tree nutrition, soil nutrients, as well as measurements we made for soil organic matter. First, I want to sort of frame what we did with our survey to almond growers as a sort of barriers to adoption, trying to understand what are some reasons why growers use these types of materials. This paper was published in Journal of Environmental Quality. First, we wanted to address grower concerns. We want to understand why are there reasons why growers would not want to use these materials. And in the graph on the right, we asked about soil food safety, nutrient availability, and costs as logistics as concerns with organic matter amendments. And on the top panel, we have users, people who use compost in our survey, who took the survey and said they've used compost in the past. And on the bottom would be non-users, people who took the survey, almond growers, but who did not ever use compost. And first and foremost, food safety is a priority concern. It really has to do with the fact that in orchards, especially in almonds, we have mechanical harvest where the almonds fall and touch the ground, and then they can come in contact with the material, which is then surface applied. We also asked growers about what are the concern that comes next. So for non-users, they think about cost next. That's their next concern, essentially, the cost and logistics of the materials. But interestingly, that flips when we asked from users. Users consider nutrient availability as the next concern. So they have had some experience using these materials. For them, they're thinking more about the availability of these nutrients and how these nutrients may impact their fertility programs. We also asked them to rate the accessibility of these materials from poor to excellent in the Central Valley of California. And what we found is that manure is a really huge opportunity. It's accessible and abundant. There's lots of dairy operations in the San Joaquin Valley, which is the southern part of the Central Valley. When it looks at the north, less so. So manure is a large opportunity. We have some ongoing projects examining that. After that, it becomes green waste compost, which it's certified compost. It's somewhat consistent in its quality. However, where it's made is more centralized, so that can increase transportation costs. And it's not as accessible to all orchards, which are grown throughout the Central Valley. That said, the technology to use these materials are somewhat simple technology when it comes to spreading. We do need more information in general from all types of effects, and looking at sort of partnerships to make sure that we can make these materials available and abundant for growers is something that is ongoing for our research program. And we're really looking at this work as a long-term investment. So since then, we've moved into an experimental setup where we looked at surface applied amendments at 9 metric tons per hectare per year with a moisture content of about 25 to 30%. We looked at different types of treatments, but all those treatments received up to 95 kilograms of nitrogen per hectare per year. Again, these were non-bearing young trees, so they're not at the upper end of the fertility rates, but they were receiving some fertilizer. So that grower unamended control was receiving some nitrogen fertilizer, but on top of that, we then applied composted manure at the above rate. which had a C to N of about 10 to 11 with total P of 0.7 and total K of 1.8%. And we also compared that with green waste compost, which had a higher carbon to nitrogen ratio, 13 to 15, with lower nutrient contents in general for both P and K. We also looked at these timing treatments. We were interested in better understanding when you apply compost, if there was a surface layer effect that could impact at harvest, or if we were leaching any of the nutrients during the winter time. We did that in a separate study looking at that. But what I can report is that when we were trying these treatments, they were applied for fall, the fall application, they were applied in 2015 and 2016 before the 2016-2017 growing season. And for the spring application of both these amendments, they were applied right after bloom, and then we took the subsequent measurements that spring. The measurements I'm going to report on today are summer leaf nutrients, post-harvest residual soil nutrients, and measurements of soil organic matter. So if we look at leaf nutrients, we looked at leaf N, P, and K, and then on the all percentages of the three for the 2 years, 2016 and 2017. And on the left, we have the source, which is really our source treatment, control, composted manure, or green waste compost, or the timing where we removed the control from the analysis and just looked at the average of when the manure was spread, when the amendments were spread during spring or compared to fall. And what we see first and foremost for leaf nitrogen, there was really no effect in 2016 and 2017, but we started to see when you compared the fall application to the spring in 2017, after 2 years, that it started to have a nearly significant difference. What we thought that had to do with is there was getting more time for the materials to decompose, and more of that nitrogen can become available over time. When we looked at leaf phosphorus levels, there was starting to be some building up of differences. However, the p-value was not significantly different, but there was certainly some sort of building up phosphorus levels, so we could start to see some of that uptake. The same came to with leaf K. In general, we didn't see very strong differences across the board over 2 years, but what we're seeing are sort of some of these trends where we start to see that the levels of leaf K were being, compared to the control, a little bit higher than they were the previous year. In 2016 and 2017, there were sort of large differences in the leaf K values between those 2 years. When we looked at soil organic matter, what we saw first and foremost in 2016, that the amendments did have an effect on the total organic carbon in the soil, with green waste compost having a significant effect, and the fall application also having a significant effect. So more evidence to show that more time to decompose allowed for more compost to build up in the soil organic matter. However, by 2017, when we make those same types of measurements, those effects were no longer significant. Now, keep in mind that we apply these materials in both years, but what we're potentially seeing here is that when the soil organic matter was perturbated in the first year, by the second year, some more of that nutrients are starting to break down compared to the first year. We also know that the grower applied more water in 2017 than in 2016. So there might have been an irrigation effect where the grower was applying more water and more of this organic matter started to break down and not necessarily build up in the soil. Keep in mind that this is measurements of soil organic matter, so we could be looking at particulate soil organic matter, which is highly labile, can break down pretty quickly. Next, when we looked at total nitrogen, we saw that the effects were mirroring the same as the total organic carbon, but the effects were not as significant. However, what we're seeing here as well is that the effects we saw in 2016, where the soil organic matter started to build up, in the first, for green waste compost, we saw those effects were no longer available significant in the second year. So keeping in mind, this is the effect of a 2-year study, and what we saw with initial effects might not be the effects that we're going to see over many years, but it does show that, for example, that when you have soils that hadn't been amended with compost, we can see large effects initially, but that does not mean that those effects are sustained over time when it comes to soil organic matter. So lastly, we then measured residual soil nutrients at the end of the season and excuse me, I didn't mention all these measurements were made from 0 to 50 centimeters. So we were looking at a fairly deep part of the soil that had access to the active root uptake and root system. Naturally, the roots would go deeper than that, but in general, we found that measuring the top 50 centimeters gives you a fairly decent overview of where we would expect nutrients to be taken up. So when we're looking at these residual soil nutrients, what we're really trying to see here is what happens at the end of the season after all the fertilizer and water has applied. We then take these samples. What we want to see is sort of what was the leftover that the trees didn't actually pick up. So we kind of interested to see how those nutrient levels might have been impacted because all these nutrients have access for root uptake. What we saw, interestingly enough, in the first year after spring application of compost, that there was a really high levels of nitrate and ammonium at the end of the season. So what that suggested to us is that when you're applying in spring, you're going to potentially have mineralization too late in the season. It's not going to synchronize with tree uptake, and that could build up to too much nitrate at the end of the season that could be potentially lost during winter rains. When it came to later, the second year, that effect was no longer significant. So potentially over time, we're starting to sort of stabilize that system, and some more of that nitrogen is going to mineralize, not as quickly as it did in that first year. When we looked at soil phosphorus levels, again, in the first year, we saw a nearly significant difference for both. Both of these materials contain phosphorus, and we were then able to measure phosphate buildup. That could have, potential issues with leaching. However, that also shows that the phosphorus is becoming available and it is breaking down. But what we also saw with leaf potassium, which is interesting, is that in the first year, we saw a large difference with manure being greater than green waste compost. Significantly greater than the control, than green waste compost being in between the two. But by the second year, those differences were no longer significantly different. This does suggest that some of that potassium that did build up in that first year was then being taken up in the second year. If you remember from the leaf nutrient figure, we saw that those effects with leaf nutrients were somewhat greater in the second year. What that does show is that when potassium, which is a really important nutrient for almonds, can be potentially readily available from these materials. And growers, in fact, use more potassium than nitrogen, and the cost of potassium fertilizer is greater than nitrogen. So when we're thinking about nutrient value from amendments, we can also think about not just nitrogen, which is a large focus in California with pollution issues, but we also want to look at phosphate as well as potassium availability. So in summary, we did these measurements with barriers to adoption. We saw that there is variation in different organic matter sources and their quality, and we wanted to better examine what was the effects on nutrient availability. We saw that organic matter additions, though not significantly different, are starting to build over time. And then I can report that as we moved into subsequent years, we started to see significant differences in leaf nitrogen, and those potassium levels in those soils continue to build up. So that is a good benefit that growers can experience from using these amendments. Interestingly, the soil organic matter initially built up, but then those levels declined during the second year. So this just is evidence to show that if you're measuring soil organic matter levels of carbon and nitrogen, that these are not going to stabilize. They're highly dynamic, and a lot of these particles are could be particulate forms and highly labile. Over time, though, we have seen those levels started to increase again and be greater than the control. And that we see an increase in N and K uptake is reflected in the residual soil nutrients. So hopefully by coupling the soil measurements with the leaf measurements in the trees, we can start to see that there is a relationship between the two, and that the trees are actually utilizing the nutrients that we're applying. We also did some measurements looking at the nitrogen in leaching, and we found that from fall application, the nitrogen was not leaching through the profile. So we continue to focus on fall application, and we didn't really see a large advantage of applying these materials in spring. Lastly, our future work is starting to look at split plots where we're going to reduce the fertilizer rates, and we're also kind of examining off-ground harvest as a way to sort of harvest almonds and catch those nuts so they don't have to touch the ground, and then dry them in that alleyway so that we potentially don't disturb any of this compost into the future. So I certainly want to acknowledge all our funders of these research, And I would like to thank everyone for joining me in this session today, and look forward to having a discussion with you or seeing you in the future. Enjoy the rest of the symposium.